Ever wondered how electric car batteries are made? These powerful energy sources are at the heart of the electric vehicle revolution, allowing cars to drive hundreds of miles on a single charge while emitting zero emissions. But what exactly goes into making these advanced batteries? Today, we'll explore the intricate process behind electric car battery production, from sourcing raw materials to assembly and testing. You'll get an in-depth look at how electric car batteries are made and why they're a key player in the shift towards sustainable transportation. Before we dive into the manufacturing process, let's start with an overview of what an electric car battery is and how it works. Most electric vehicles today use lithium-ion batteries, the same technology found in your smartphone or laptop, but on a much larger scale. These batteries are composed of multiple cells grouped into modules, and several modules are then combined to create a battery pack. Each cell contains three main components: the anode, cathode, and electrolyte, which work together to store and release energy. When the battery is charged, lithium ions move from the cathode to the anode, storing energy. When you drive the car, these ions move back, releasing energy to power the electric motor. This basic principle is simple, but the manufacturing process behind it is anything but. Producing a high-capacity, long-lasting, and safe electric car battery involves a complex series of steps, all aimed at maximizing efficiency and reliability. Before we keep going, please take a quick moment to give this video a thumbs up and leave a comment about your thoughts on electric car batteries. And don't forget to subscribe and turn on notifications so you don't miss any of our future episodes. Alright, let's keep going. Electric car batteries begin with raw materials, most notably lithium, cobalt, nickel, and graphite. These elements are crucial for the battery's performance, but sourcing them's a global operation. Lithium is typically mined in countries like Australia, Chile, and Argentina, while cobalt often comes from the Dominican Republic or the Congo. Nickel and graphite are sourced from various locations worldwide, including Canada, Russia, and China. Once these raw materials are extracted, they undergo extensive refinement to ensure they meet the high standards required for battery production. For instance, lithium ore is processed through a series of chemical treatments to extract lithium carbonate and lithium hydroxide, forms suitable for battery manufacturing. Cobalt and nickel also undergo purification processes to remove impurities, as any contamination can impact the battery's efficiency and longevity. The refinement process is energy intensive and requires strict environmental controls to minimize the impact on surrounding ecosystems. This is one of the challenges the industry faces as it scales up production to meet global demand for electric vehicles. Companies are working towards developing more sustainable mining practices and exploring recycling methods to reduce the need for new raw materials. As we move forward, finding ways to minimize the environmental footprint of battery production will be crucial. Once the raw materials are refined, they're used to produce the battery's electrodes, specifically the cathode and anode. The cathode is one of the most important parts of the battery, as it determines the battery's capacity and voltage. The cathode is typically made from a combination of lithium, cobalt, nickel, and manganese. These elements are mixed together to form a compound known as a cathode active material. This mixture is then applied as a slurry onto thin sheets of aluminum foil. The slurry is composed of the active materials, a conductive agent like carbon black, and a binding agent to hold everything together. The aluminum foil serves as a current collector, allowing electrons to flow in and out of the battery. The coated foil is then dried to remove any moisture and pressed through rollers to ensure the slurry is evenly distributed and compacted. This step is critical, as an uneven coating could lead to poor battery performance or even safety risks. After pressing, the sheets are cut into individual electrodes. These electrodes are then stacked or wound, depending on the battery's design, to create the cathode portion of the battery cell. The precise formulation and thickness of the cathode play a crucial role in determining the battery's energy density, which directly impacts the range and performance of an electric vehicle. Now, let's move on to the anode. The anode is usually made from graphite, a form of carbon that can hold and release lithium ions efficiently. The process of making the anode is similar to that of a cathode. Graphite is combined with a binder and a conductive agent to create a slurry, which is then applied to the thin copper foil. Like the aluminum foil in the cathode, The copper foil serves as a current collector. The coated copper foil goes through a drying and pressing process similar to the cathodes, ensuring a uniform and compact layer. This uniformity is vital for the battery's performance and longevity. Once dried and pressed, the anode sheets are cut and stacked or wound together with the cathode to form the battery cells. One of the innovations in anode technology is the use of silicone to enhance the performance of traditional graphite anodes. Silicone has a higher capacity for storing lithium ions than graphite, but it also expands more during charging, which can lead to degradation. Manufacturers are experimenting with silicone graphite composites to increase energy density while maintaining durability. These advancements are part of the ongoing effort to develop batteries that offer greater range and faster charging times. With the electrodes ready, the next step is preparing the electrolyte and assembling the battery cells. The electrolyte is a liquid or gel substance that allows lithium ions to move between the anode and the cathode. It's typically made from a lithium salt dissolved in a mixture of organic solvents. The formulation of the electrolyte is critical. It must be stable, conduct ions effectively, and remain functional across a wide range of temperatures. Once the electrolyte's prepared, it's time for cell assembly. The battery cells are assembled in a highly controlled environment called a dry room, where humidity levels are kept extremely low. This is because lithium and some other components react easily with moisture, which could compromise the battery's performance or safety. In the dry room, the anode, cathode, and a separator are stacked or wound together, depending on the cell's design. The separator is a thin, porous material that keeps the anode and the cathode apart while allowing lithium ions to pass through. It's essential for preventing short circuits, which could lead to overheating or even fires. The assembled cells are then filled with the electrolyte, and the cells are sealed. This entire process must be done with precision and care, as any contamination or error could impact the cell's performance and safety. Once the cells are assembled, they're grouped into modules. A typical electric car battery contains several modules, each made up of dozens of individual cells. These modules are then combined to create the battery pack, the final and most crucial component that powers the vehicle. The modules are assembled in a precise manner, ensuring that the cells are aligned and properly connected to the electrical system. Thermal management systems are integrated within the modules to regulate the temperature of the cells. Overheating can reduce battery efficiency and lifespan, so maintaining optimal temperature is critical. Some systems use liquid cooling, while others may use air cooling methods. Battery packs also include a battery management system, which monitors the health and performance of the cells. The BMS tracks the state of charge, voltage, temperature, and overall health of the battery, ensuring safe operation and optimizing performance. It's like the brain of the battery, making real-time adjustments to ensure everything runs smoothly. Before the battery packs are shipped off to be installed in electric vehicles, they undergo rigorous testing and quality control procedures. Each battery cell, module, and pack is tested for various parameters, including capacity, voltage, temperature response, and safety. For instance, cells are charged and discharged multiple times to measure their performance and ensure they meet the manufacturer's standards. Thermal testing is also conducted to simulate real-world conditions. Engineers expose the battery packs to extreme temperatures, shock, and vibration to test their durability. They need to ensure that the battery can withstand everything from cold climates to high-speed driving without failure. Safety is a top priority. Battery packs are subjected to impact tests, drop tests, and even fire tests to evaluate their ability to withstand accidents. Once the batteries pass all these tests, they're inspected one final time to check for any manufacturing defects. The rigorous testing and quality control procedures help ensure that each battery pack is safe, reliable, and capable of delivering the performance that electrical vehicles promise. So what does it take to make an electric car battery? As we've seen, it's a complex process that starts with raw materials sourced from all over the world and ends with rigorous testing to guarantee safety and performance. Every step of the process, from refining materials to assembling the cells and packs, is crucial for creating a reliable battery pack that powers the electric vehicle revolution. So the next time you see an electric vehicle on the road, remember the incredible journey that its batteries undergone, from raw materials to the final product. Let me know in the comments what you think's the most exciting part of electric car technology. Where do you see the future of EVs heading? Don't forget to subscribe to the channel and hit that thumbs up button to give the video a like. Until next time, keep learning.